Welcome, everyone, to the ultimate quantum panel. We have 40 minutes, 5 awesome quantum panelists from all around the globe, so enjoy. The main question is, how do we make quantum real? How do we make sure that this dream really comes true? And what does it take to scale, to adopt, and to integrate? So we will talk about the investment landscape, industry adoption, and the integration with AI. So we'll first start with a round of introduction. My name is Martina. I did my PhD in quantum computing a couple of years ago in Munich, and I'm co-leading our quantum activities at McKinsey Co.
Hello, everybody. My name is Fernando Dominguez. I'm vice president at SandboxAQ. The A is for AI, and the Q is for quantum. And I'm going to share a little bit today about how we converge the two technologies to solve problems today.
Good afternoon. I'm Dr. Satyam Priyadarshy. I'm the CEO of Reignite Future. I did my PhD something like 34 years ago, applied quantum mechanics to biophysics, and I've done some of the largest calculations of biomolecules in the world, especially DNA and cytochrome C and others. And last 10 years I spent in energy industry, trying to see how AI can transform this industry. And now looking at a combination of multiple technologies to transform complex industries.
Good afternoon, everyone. My name is Carlos Abellan. I'm one of the co-founders and CEO at Quside, a company based in Barcelona. We develop semiconductor chips and products combining photonics and quantum for applications in cryptography and high-performance computation.
Good afternoon, everybody. Steve Suarez. I'm the CEO of HorizonX. I am a senior advisor to Mitsubishi Corporation, Bain & Company. I used to be the former head of innovation at HSBC for many years. I left after 20 years, a recovering banker. And now I also teach quantum strategy at MIT. So if anybody's interested in doing any education, we're launching a course in the next 60 days.
Good afternoon, everybody. Christophe Jurczak, former physicist. I did my PhD cold atoms physics with Alain Aspect, the Nobel Prize for 2022, quite some while ago. And I'm a founder and managing partner at a venture capital fund that's called Quantonation, that I've started back in 2018. We're based in the US and in France. We've invested in 32 companies so far, a little bit more than 150 million, and looking forward to share our experience.
Thanks, everyone. Then let's start with the first question. So in 2023, we have seen the investments in quantum technologies slightly decreased by 27%. However, when we compare this to the overall numbers, like the overall startups, we see a decrease of 38%. So there is still quite some traction in quantum technologies. So what do you see, what kind of mechanisms need to be in place to ensure a continued investment that we need to solve the research, but also the engineering challenges going forward? And maybe, Steve, you want to kick us off here.
Yeah, thank you. And I know the report you're talking about, McKinsey came out with a really good report in April of this year. So if you really want to learn about good insights and deep knowledge, I definitely recommend looking at that report. In that report, it talked about a decline in investment. And I don't see that as a negative thing because a lot of attention got taken away from quantum because of AI. Everybody, all discretionary budgets got moved and said, hey, we're going to focus on AI. I used to work at a bank, I won't tell you which bank, and at that bank, they took our quantum engineers and said, hey, we want you to focus your energy away from quantum and focusing on AI. And that's because it created AI FOMO. And so everybody was fearing of missing out. My suggestion is to get involved now because you don't want quantum FOMO. Look at the talent, start preparing yourself, and start educating yourself.
Yeah, so I believe actually we will reach this year probably we will be back to the level we had in 2022, which is close to 2 billion invested per year, which is not a lot. I mean, it's a relatively small asset class. So variations have an impact. And what happened, from my perspective, is things have been slower. Some funding rounds have been delayed with time. But we're catching up. So definitely not, sometimes I hear about quantum winter, and it's a word I really hate, I must say. I think things are happening where it's, from our perspective, we're an early stage investor, but where things are a little bit more challenging is late stage for mature companies, Series B plus. And we start to have a few of these companies, actually. So the sector is relatively young. I would say it started for me with IBM putting the first qubits online back in 2016. So it's not a long while ago. And now we have companies in various segments, communication, sensing, compute, that start to be large enough, that are maturing. And they need more cash, obviously. 50 million rounds, 100 million rounds, and more, especially for quantum computing. So that's where I believe there's a little bit of a weakness in the ecosystem for funding, late stage. Early stage, from our perspective, is quite healthy, actually. We find co-investors for our deals. We find investors into our fund as well. We're raising our fund at the moment. And yeah, we're moving forward, a bit slower than Fund 1, but we're halfway there on the 200 million. So I think situation is contrasted, but definitely moving forward. But there are inefficiencies to fix, then that's for sure.
Yeah, and we also saw this in our numbers that more than 70% actually from an investment go into companies that were founded 2019 or even earlier. So that's clearly shown by the numbers as well. And then, Carlos, do you want to add something from a startup perspective? What kind of mechanisms there should be?
So most of these numbers also depend a bit on the sector, right? We talk quantum technologies, but we have different things within quantum technologies. We have computing, we have sensing, we have communications. Probably the cycle is not exactly the same. So for instance, we've seen in Europe quite sizable investments for quantum communication infrastructure called EuroQCI. So there is still investment, and I guess those mechanisms of both private investment on one side, public-private initiatives that go more on the commercial side, are being extremely useful. So at least on that perspective in Europe on quantum communications, there is a significant amount of capital, also in terms of access to matching funds from EIB or CHIPS Act right now, right? So I think in the next few months and years, we're going to see significant growth, both on public-private partnerships and private capital.
Yeah, I also advise a group called Global Quantum Intelligence, and if you look at the report, the data for 2024 compared to 2023, overall, yes, in 2023 the investments reduced, but if you look at 2024, there has been significant amount of investment. But the most important thing is the actual investment, or the ticket size as we call it, has increased roughly about 30%, especially in quantum hardware areas. And also in what we call it a mid-stack and quantum software, which earlier, if you look at last 2-3 years, there has been less investment in the quantum software side, but 2024 see an uptick into that. And I think my fellow panelists just talked about quantum communication. That has pretty much remained the same over the years with small changes. But I think this good investment in hardware certainly will accelerate, I think, in the next coming years.
My turn? I'm the last one. How many investors do we have in the room? Perfect, like 10, 20%. So we know investments usually go like trends. There are waves of investment. We are in the middle of the AI wave that is attracting like 90% of investments. Next one might be robotics, might be quantum. If you're thinking about quantum, 100% Quantonation, they know what they're doing. They've been doing this for 10 years, the only one. Christophe, you'll pay me a beer later.
Thank you.
They've had great returns so far. But what we need to understand is that at SandboxAQ, for example, we've been working converging the technologies, AI and quantum technologies together. It's not about, as Steve was mentioning, either I do AI or I do quantum physics. It's combining the tools to solve one problem. You invest in a solution. It's the solution that is giving you the return. Let me give one example. Many investments today go to LLMs, large language models. But we are already perceiving and seeing that with text and images that are what large language models are based on, we're not going to really solve the hard problems. The climate change problems, the hard problems of the industries, energy, logistics, computation, that requires more science. So what we're working on converging AI and quantum is large quantitative models. Think about the same principle that builds on large language models, but creating them with mathematics, with science, with molecular chemistry, with biology, with physics and quantum physics. Those models help you solve real problems, like, for example, molecular dynamics. We work with pharma companies, just to give an example, to solve Alzheimer's. And we are able to simulate those interactions between the molecules using AI and quantum physics models to get to clinic 6 years earlier than was expected. And that's solving a problem, and that's bringing a lot of return from the investment. So it's about converging the technologies and using them together to solve the problem.
Thanks a lot. Since you now touched on quantum and AI, I'd like to follow up on this and go a bit deeper into that topic as well. So where do you think that AI and quantum technologies can best complement each other? So maybe you can elaborate a bit on that. And then if you have a use case, the killer use case or not, but if you have a use case where AI and quantum technology really come together nicely, can you please share with us? That would be super interesting.
Yeah. I think I can start. So first, we have a white paper on AI and quantum that you can find on our website. I believe there are two angles to it. You can use AI to improve quantum technologies, and you can use also quantum technologies to benefit AI. And I will focus maybe in my use case on this second category. And by the way, there's a very nice paper by NVIDIA that was out 2 days ago, I think, on this topic. It's on the archive. You can find it easily. It's in the field of computational drug design that was mentioned a little bit earlier. So there's a conception sometimes by some people that AI will, on its own, change it all. You will design new molecules all of a sudden. And it's going to be fantastic, obviously. The challenge is really in the quality of the data, as you know, garbage in, garbage out, which is the thing that people are saying in this sector. And what is working really well, and I have an example with one of our portfolio companies, it's called Qubit Pharmaceuticals. We do computational drug design. You use quantum to do simulation at the beginning of the process. It's generation of synthetic data, if you want. The simulation, which is very precise, gets you to generate data, and then you can train your models with high-quality data. Because pharmas are not sharing their data publicly, obviously. I mean, there's a lot of IP there. You cannot measure everything, but you can simulate with quantum computers and high-performance computers as well. It's a combination, actually. The reactions, molecular dynamics, versions that are much more evolved than that have been developed. You can simulate relatively large systems now, up to 50,000 atoms, which is relatively big already. So do the synthesis of the data, then train your model, and then you get the molecule. I think it's a good combination. If you think in terms of workflow, quantum plays a role, AI plays a role in the workflow, and then ultimately what matters, obviously, is what the customer will have. He will not care too much whether it's AI, it's quantum, or what. I mean, he wants a good molecule for Alzheimer and for other pathologies. But I think this one is a pretty good example.
Thanks for sharing. And Steve, do you want to add to that?
Yeah, I mean, the benefit of going first, you get to put that use case, and then I have to come up with something else. Now, listen, I think we're a very interesting time right now. There's this intersection between AI, error correction, and the quality of qubits, and that intersection makes this industry a very, very interesting time to be in. And I think AI has multiple things, and I agree with your point about how right now AI can help quantum. Eventually, quantum will be helping AI. And in one specific use case is around error correction. You guys know that quantum computers are sensible to noise, and so we can use AI to look at the error corrections to predict and analyze some of how the hardware is going to react so the error correction can get better. Part of quantum is not only you need better qubits, you also need to focus on the error correction, and I think that's going to play a key part in making this industry and making this more powerful and making it useful across all industries.
So Fernando, in addition to what you shared earlier, do you want to add something here specifically for use cases?
Yes. let me tell a story that I want to build on what Christophe was saying about synthetic data and generated data. SandboxAQ is a spin-off from Google X. We left Alphabet 3 years ago. I remember when I first arrived to Google X in 2015, everybody was talking about self-driving cars. And you only start seeing them today, really. If you go to San Francisco, you can take a self-driving car, and they are all around Phoenix and different cities in the US. But back in the day, I think we might have like 30 or 50 cars on the streets taking data. And we realized that we're never going to learn fast enough with 50 cars taking data. The amount of interactions and the amount of possibilities of cases that happen on the streets are too big. So they decided to create a simulated model, a virtual world where you have self-driving cars driving in a virtual world, learning much faster. So you might have like 1 million miles of learning experience from the cars in real life, but you will have 10 million miles on the virtual world where you are also learning. That's exactly what we are doing today with what we are 9 years later. The computational capabilities of GPUs allow us to run much better, much faster simulation worlds on the, for example, molecular world. So we run the trillions of combinations that exist in the molecular level to be able to generate that data that does not exist today on the internet, does not exist today in company proprietary data. You need to generate that new data to understand the combination and the interaction of those molecules to find the perfect compound, to find the perfect drug, to solve Parkinson, to solve neurodegenerative disease. So that's only possible by converging the two of them, the AI and the quantum. But let me give one more example that it's very easy. When we started working on sensors, because one of the things that we realized 7 years ago when we started working on this field was that quantum technologies is much more than just quantum computers. Quantum computers are great, and they're gonna revolutionize everything, but they are still on the research phase, still not business ready. But you also have quantum sensors, you also have quantum simulation, and you have post-quantum cryptography and quantum communications where Carlos works, for example. And that's very important areas. So on the sensing side, what we discovered that we have magnetometers for years. We have tons of data from magnetometers that are sensing what happens all around. If you've done an MRI, who's been here in a hospital taking an MRI once? Where it's as cold as this room, and you can't move, and you cannot bring any metal because the machine is so sensitive that they just want to sense your brain or the part of your body that they want to sense, so they don't want any interaction. Today, with AI, we are able to denoise that kind of data. So we are enabling the next generation of sensors. We work with the Air Force, for example, to have a magnetic navigator. So it's the size of a shoebox. You put it on the airplane, and you are able to find where you are on the Earth by measuring the magnetic field of the Earth, just like birds or whales do. They navigate around the world with magnetic field of the Earth. But before, we were not able to do it. We had the data, we couldn't read it. Today with AI, we denoise that data, and we are able to tell you where you are when you lose GPS, which happens, by the way, very often, especially in the Middle East and near areas of conflict. So that's an example of like using sensors, magnetometers that are quantum machines, and AI to be able to read what the sensor is really telling you.
Amazing. And then speaking about bringing different technologies together, I'd like to follow up with a question on adoption, because what we currently see in the ecosystem is a lot of momentum in terms of partnerships. So partnerships between hardware players and industry players, but also software players with industry players, the three of them all together. So what do you think comes next? What's the critical next step to move forward? Because the key killer use case might not be there, but what's coming next?
I think Steve has been thinking a lot about this.
But I do, but I want to give these guys some chance to talk. Do you?
So there is one thing, and specifically maybe our sector is more on the intersection that quantum and security, maybe AI is also having on how we protect and communicate data, right? One of the things that we figured out, and you touched on it before, is not that much about whether there is a Q and it's quantum, it's about what is the problem you're solving and how are you helping customers protect data better, right? And the reality is that when you go away from a lab or when you're starting up something and deploying it in operations in an environment that people are really running their stuff, you cannot do just anything. You need to adapt a lot to the conditions of that environment, right? You cannot just come in with something new and try to change everything that was in there. You need to adapt. So for that, we've been, for the last 6 months, we've been working very intensively on how we bring the technology inside of the stack of how people are protecting data today, so that with a single line of code, you can just upgrade your infrastructure without having to touch anything else, right? I believe that intersection between different vendors, hardware, software, we, for instance, partner with both hardware and software players, going together and offering a broader solution in the way that the customer doesn't even realize that they are deploying something new is fundamental for the success and the adoption of the technology. So that's one of the key areas that I would emphasize.
You know, it's easy to say that quantum and AI will work, and in theory, that's a pretty good understanding that these two technologies or these two solutions can work together. But adoption of these by themselves is hard, and combining that becomes even harder. When it comes to looking at complex industries like energy, if you think of it, what problems are we solving in energy? If you look at energy, there are fundamentally workflow issues and new material issues. And look at the AI implementation, the industry is roughly about 10 to 15 years behind in adopting AI solutions. One of the fundamental challenges that there is not enough what I call the talented workforce to really implement the solutions. When it comes to quantum, many of the energy industries, since we are sitting in Abu Dhabi, it's a place for energy. There is not enough talented people who actually understand how energy problems have been solved with these two technologies, even though the industry has been talking about it. The examples that we talked about in materials or drug discovery, they are very mature. And one of the things that you do in those industries is you can actually use quantum algorithms to actually do what is called inverse molecular design or inverse material design, which can be actually applied to energy industry as well. So there is a learning curve that needs to be there from cross-industry that will help you increase the adoption rate of these two technologies. The second part is that one is the lab adoption and then scaling. Some of these complex industries like manufacturing and energy companies and transportation and aviation, while you can build these solutions, how do I scale them? Right? Computer hardware, quantum hardware is still far behind for which is to be commercially viable. But at the same time, are we ready to develop the software stack that is needed? If those who have done any programming in the life or HPC programming, when we went from linear programming to parallel programming to grid computing, it's a learning curve for all of them. Same thing will happen with combinations of artificial intelligence algorithms and quantum computers, because in quantum computers, yes, we are 24 logical bits. People are talking about 1,000 qubits. But for solving a real-world problem in energy, transportation, and such industries, we need lot many qubits. They will not be in single unit. That means we need to actually develop software that can really look like a quote-unquote parallel software. So that kind of learning curve is needed. That kind of implementation is needed. I think in the morning keynote, there was some discussion about it. How do we get people ready for these kind of things? That means we need to really change how we teach these things in our universities. So that's the fundamental challenge when it comes to adopting these technologies.
Yeah, thank you. And Fernando, thank you for the plug, because you know that I'm very passionate about this. And looking at the industry, and part of what I do is on the consulting side. And oftentimes what a lot of companies do, hardware, software companies, is they come to these big organizations and say, hey, let's do a POC. And so they go to somebody in middle management, they say, let's do a POC. They try to do a POC. It might work, it might not work. But what happens is that POC sometimes is not tied to the company strategy, and the senior people in the organization don't really know what's going on. They get frustrated, the company gets frustrated because it's really not moving forward. And so part of what I suggest and focus with my clients is I want to have a holistic approach to quantum computing. So I start on the education. We educate the board we have the board understand what is quantum and what isn't quantum. And while everybody talks about quantum, there is a lack of education and reality of what it is. We want to also dispel the hype. Everybody is worried about, you know, the security side of it. So the board understands both security, the opportunity, and the threats. Once the board considers us as trusted partners, then they say, hey, why don't you come in, help us write our strategy, and we help them tie their strategy to quantum, not the other way around. And so we look at how quantum can help them deliver on their strategy. Now you've got the board, you've got the C-suite behind you, then you can start deciding what are the POCs that have the best opportunity for success, and then now you're going into it as a partnership with the organization, and I think that's a good approach. And so when companies get happy about selling POCs, that's great, but if you want to make it sustainable, my suggestion is start from the top and work your way down.
Yeah, I think it's a very good point to go beyond POCs. That's something I'm putting in my slides these days. So POCs, proof of concept, relatively small projects, 200K to $1 million, I'd say. A company works with a corporate, and the problem is it's not necessarily at the right level, on the right problem, and at the end of the day, nobody really capitalizes on that. And I think that has been okay to start the sector, but now with the level of maturity that we have, we need to go beyond that for two reasons, I think. One is I think the community as a whole has not been very good at crafting the narrative about the usefulness of quantum technologies. One reason is probably that it was not mature enough from the hardware perspective. Well, you need to build the stuff and then to apply it to problems and develop applications. But as a whole, I mean, if I would be sitting there, I'd think, well, I mean, what are they talking about? I mean, what are these applications? What is it good for? And I think the community has not been very good, and there's an effort to be done in that respect. I'm pushing my startups a lot to work on white papers, for example. And they don't want to do it, but you have to do it to position your technology with respect to alternative technology. Classic to benchmark is a key word there, because usually scientists, physicists, when I ask, okay, what's the best application of a quantum computer, they tell me simulate chemistry. And then I ask the chemist, I say, I have got perfectly good computers. I don't need a quantum computer. And what you need to do is have the physicist talk to the chemist and with the end user also in the loop, so that this interdisciplinarity in the end brings you to the next level, beyond the POC. There's this aspect, the narrative, and a recipe I believe in very much is also working on regional ecosystems at the regional level. It's the right level for innovation. And bring at the same place, and the place matters, the corporate users, the developers of a technology. Could be different technology, could be different kinds of quantum computers, could be test beds as well, but at the same, in the same place. And I think that's really important. And you can start to have connections being built, stakeholders from the government who will understand better how things are working. I've got some examples. I've got one very good one in Quebec. It's a small ecosystem, but super dynamic, and we've done a lot of good things. It's in Sherbrooke. You have the startups in the same place, 3 or 4. You've got the students from the university. You've got a quantum communications test bed, 2 quantum computers, all within, wow, 5,000 square meters. I mean, and they're working together. Seriously. And I think that's a way also to go beyond the simple POCs that were okay for a while, but we definitely need as a community to go beyond that already now.
Thanks a lot, especially also bringing this topic up about hubs and clusters that we see emerging globally. I think that's a very, very big driver for technology and moving forward. So Carlos, do you want to add something from a startup perspective?
I just wanted to add something on you mentioned, Steve. So we've been on both sides of those type of conversations, right? Pushing for a POC that ends up nowhere. And one of the things that we're seeing lately, it's actually the reverse order, right? A lot of companies, big companies are coming, saying the board has decided we want to be quantum safe by this date. And then roll backward, and then they make a plan. And the dynamics are radically different, right? So just to stress that's something that is happening, and as from the startup perspective and delivering the technologies is making a world of a difference.
So one of the things that is important to I really increase the adoption of it to change the 2 concepts. One, that Steve and others talked about proof of concept. We all know that AI works, we know that quantum works. Question is, what is the value to my organization? Where do I get the maximum value? And that value has to be measured not in terms of just on ROI, that's what the traditional return on investment. Because with these technologies, you're not going to you spend 1 million today and you will recover your 1 million tomorrow. What we have to look as a company is what is my return on innovation. When we build new solutions for the company, over the 5-year, 10-year, what is the return that we are looking at? When you start looking at that, then your investment automatically increases, and actually you can adopt this technology meaningfully for the business.
Okay, then I have one last question for you, and we can go one by one. If you think about one thing, how industries can best prepare for a potential ChatGPT moment. We recently get this question a lot, actually. What happens if there's a ChatGPT moment for quantum? So what would you think is like the one thing industry could prepare?
We discuss this a lot with what will be that moment. We believe a lot that we don't know what it will be or when, but we're pretty sure it's going to happen in between the next year to 10 years, right? And if you think about the ChatGPT moment, the team that originated everything was at Google with Attention is All You Need, published in 2017, for example, with the Transformers. And so it took them like 5-6 years to that technology really start getting out. And we started working with them in 2019, 2020, applying, for example, quantum technologies, tensor networks to the Transformers to make them much faster. So if you feel like you missed the GPT moment, because you're still catching up, you need to be ready. That moment is going to come. It's a wave that it's going to come. But for that, you need to be ready. You need to have the talent. You need to have the decision makers understanding the possibilities of it. Let me give an example. The energy industry, very, very important in this region. They need to understand what are the possibilities with AI and quantum together on the industry. We work, for example, with oil and gas companies here to help improve their chemistry processes, to use the waste from their refineries. We help them doing grid optimization. Logistics problems is a quantum problem used for, you can start doing with GPUs. When that wave comes, you need to be ready. And to be ready, you need to start playing with these technologies, so when that comes, it's going to happen. If you like surfing, for example, just to make an analogy, a surfer not only needs to have a good wave that comes, but needs to be ready, so when that wave comes. If you don't know how to surf, the wave is going to crash you. And if you're a really good surfer, but the wave is not good, you're going to get bored on the water. So you need a good surfer with a good wave at the right time.
I believe, ChatGPT moment, I think it's hyped, basically. I think industry knew about the artificial intelligence and its value, but people kind of started ignoring it for a very long time, and so now they are struggling. Every leader wants to know what this AI is, which existed for 50 years in practical sense, in commercially viable sense. Same thing with quantum. I think people are fully aware that it is going to impact the businesses in a big way. The question is, I think one that we already said, that it is about talent readiness. And talent doesn't mean that only the workforce. It is the leaders and the board members that they have to really understand how much impact it is towards their business and how resilient business they really want to build in 5 years, 10 years, 20 years, whatever their roadmap is. That's where we miss out. We try to benchmark against each other rather than benchmarking against ourselves. How do I want to build our business 5 years from now? And based on that, we should really invest in this technology.
Carlos, go ahead.
I'd say this moment that is relevant, at least for what we do, is when you have a large enough quantum computer that can break your data or anything related to what our communication security or privacy has to do. The thing is that organizations know that because there are new standards as well, you will need to transition to these new states in which you're secure to quantum computers. The downsides of being early are almost zero. The downsides of being late can be business continuity, right? So I'd say from that perspective, being early is just zero risk, and that's what companies are already starting to do. So that would be my say.
And I completely agree with that sentiment. You got to start now. The later you start, the more costly it's going to be and complex. And at some point, it'll be game over. So this is not a technology you want to come in second place. I've got 3 points. Education, education, education. I'm going to be a little cheeky. We are doing education. You need to understand what it is, what it can do, and start educating yourself now. And so that's why I'm really pushing hard through this course that we're launching at MIT on quantum strategy for corporate executives, the people in this room, and government leaders. So I'm a big proponent. Educate yourselves and understand what's going on.
Can you, and before we move to Christophe, can you elaborate a little bit on this educational part? So where do you think are the bottlenecks in terms of education?
You know, I think they talk about hype and everything going on. You got to know what it is and isn't. Quantum computing will not replace classical computers. Quantum computing actually are for slivers of your projects, and you need to know, I think you mentioned simulation, optimization, machine learning. Quantum will only solve specific use cases. So you got to know, how do you work between quantum, classical, how to use the cloud. There's a lot of muscle memory that needs to happen so that you can understand it. I use the analogy, you're going to run a marathon. This is a marathon. You're not going to show up the day of the marathon without training, without eating right, without doing it. If you do, you're going to have a hard time during that marathon. This is going to be train before, get your plan together, so that once that moment hits, you're ready for it. Does that answer your question?
Makes sense. Thanks a lot. Christophe, some final words.
Oh, yeah, final word. So to add to these excellent words, one thing I just want to mention is hardware. I think behind ChatGPT or GPUs is NVIDIA, ultimately the ultimate beneficiary of all this. One key challenge, I think, with quantum computers, and I believe there will be a ChatGPT moment, but then you will need to have the hardware, and the hardware running efficiently 95% of the time, at least, like a regular, good HPC supercomputer is working. It's not necessarily the case for now. I mean, we have still companies, some startups that are thinking more in terms of scientific challenges, like nice experiments, but that's not what we need. We need machines that run all the time, that are that have a price that is accessible. That's not $1 billion to buy a quantum computers, and that's maybe something that's a little bit overlooked from my perspective. So we need in these companies more engineers, more people working on the project management, on the delivery, on the construction of these machines beyond the science, beyond achieving first page of nature. The point is having a machine that works and having more machines. Every software company that I know in quantum is upset about the machines, actually. There's not enough. We calculated something. There are probably these days 120,000 QPU hours, so quantum processor hours per year that are available. So it's not a lot, actually. It's really peanuts. We need maybe 10 times that over the next couple of years, because when we have the killer app, and it's going to come, then we need to run on the computers. If we don't have the computers, we will be, we will have another challenge as well, and customers will be upset, rightly. So I think bringing at the same time the application, finding the right application, but making sure the machines are on time and not lab prototypes, but real true machines you can put in a compute center, but you can put here as well. There are tons of questions about export controls, etc., that we cannot go into, I guess. But everybody must have access to a quantum computer, and that's what we'd like to do. So this is, to me, a key problem as well, not to neglect.
Fully agree. Thank you. And thank you so much. I hope you, as audience, enjoyed the conversation as much as I did, and I hope you panelists as well. So huge thank you to all of you for sharing your thoughts and for the conversation.
Thank you.
Thank you.